This is a National Training Center Tech Byte. This Tech Byte covers liquid immersed transformer insulating fluid, specifically mineral oil, and carbon monoxide and carbon dioxide gases. Tech Bytes are quick videos that will be from 3 to 8 minutes in duration to cover a very specific topic or issue associated with the world of electricity. This Tech Byte topic is associated with insulating fluid used in liquid-filled transformers, more specifically the two compounds carbon monoxide and carbon dioxide. This training is derived primarily from IEEE standard C57.104-2008 IEEE Guide for the Interpretation of Gases Generated in Oil Immersed Transformers. This training must be applied within the context of IEEE standards and is meant entirely to act as a quick explanation of one or more specific gases and a refresher to the experienced engineer or technician. The thermal decomposition of oil-impregnated cellulose insulation produces carbon oxides, specifically CO and CO2, and some hydrogen or methane, H2CH4, due to the oil. CO2 is not a combustible gas, whereas CO is. The rate at which they are produced depends exponentially on the temperature and directly on the volume of material at that temperature. Because of the volume effect, a large heated volume of insulation at moderate temperature will produce the same quantity of gases as a smaller volume at higher temperature. The thermal decomposition of cellulose and other solid insulation produces carbon monoxide, CO, carbon dioxide, CO2, and water vapor at temperatures much lower than that for the decomposition of oil, and at rates exponentially proportional to the temperature. Because the paper begins to degrade at lower temperatures than the oil, its gaseous byproducts are found at normal operating temperatures in the transformer. A transformer, for example, that operates at or near nameplate rating will normally generate several hundred ppm of CO and several thousand ppm of CO2 without excessive hotspots. The ratio of CO2 to CO is sometimes used as an indicator of the thermal decomposition of the cellulose. This ratio is normally more than 7. For the CO2-CO ratio, the respective values of CO2 and CO should exceed 5,000 parts per million and 500 parts per million in order to improve the certainty factor. In other words, ratios are sensitive to minimum values. As the magnitude of CO increases, the ratio of CO2 to CO decreases. This may indicate an abnormality that is degrading cellulosic insulation. We have 4 conditions that we use to grade our transformer's health. Condition 1 is the lowest level, and at condition 1, CO should be less than 350 parts per million, CO2 less than 2,500 parts per million. At condition 2, we will see CO between 351 and 570 parts per million, and CO2 is 2,500 to 4,000 parts per million. What you'll notice about the condition 2, this is the point at which really we can even start thinking about this ratio, but even the CO2 is still going to be too low to consider a valid ratio. At condition 3, we're getting into a situation where the ratio that we just described may apply. At condition 3, the CO will be between 571 to 1,400 ppm, or the CO2 will be between 4,100 and 10,000 ppm. At condition 4, which is the worst condition of the transformer and the oil and gases, CO is going to be greater than 1,400 ppm and CO2 greater than 10,000 ppm. CO and CO2 are found in all liquid immersed mineral oil transformers. They are primarily produced by the breakdown of the cellulose and solid insulating material. When transformers are run close to full load, they can continue to produce CO and CO2 depending on the temperature. The static levels and even some increasing levels are not a reason typically for alarm if no other indicators are present. Keep in mind that thermal aging reduces electrical component life. CO and CO2 levels that continue to rise annually can be indicative of and point toward a premature failure. Furan testing should be conducted if there is any concern over the increasing CO and CO2. Furan testing is covered separately. This is the end of this tech bite on carbon monoxide and carbon dioxide as it applies to liquid immersed transformer insulating fluid.